Hey guys, this is Raleigh Jones, CCIE 37264 with Router Beast, and we're going to be taking a look at some BGP configuration today. We're specifically working on iBGP, an iBGP topology that we're going to be setting up here. And actually, we've already set up this fantastic topology in a previous video. And specifically, we're working with routers 4, 5, 6, 7, 8, and 9 here. Routers 1, 2, and 3 will be used for other videos in the future. But for right now, we're just working with this BGP environment right here, where we'll be setting up iBGP, an iBGP full mesh configuration. And so a couple of things about BGP and iBGP, keeping in mind just a couple of basics about BGP in general. Remember that neighbor statements have to be configured on both sides. So when we set up the BGP configuration and we turn it on for that autonomous system number 65047, we have to configure it so that there are neighbor statements on either side. So router 4, router 7 will have neighbor statements on either end. And so we'll be seeing that in just a moment here. Another thing about BGP is that neighbors must be directly connected, or they have to at least have a specific route to that neighbor. Keep in mind, default routes will not work. So in other words, I have to have full IP connectivity to be able to ping or to be able to reach that neighbor directly. Because remember, BGP does use TCP to build upon, it builds upon TCP port number 179 specifically in order to do its communication, in order to set up its BGP peerings. And so there has to be TCP/IP communication from a network perspective, from an IP route perspective. So show IP route, when you look at the routing table, you have to be able to see that there's a route to that particular neighbor in order for that peering to work. Another thing is those advertised networks. When I set up a network statement under the BGP process, the BGP router process, there has to be a matching network in the routing table that associates with that network. And that's sort of interesting. It has to actually match down to the subnet mask. It has to actually be an exact match, so to speak, in order for that network to be advertised. And then finally, and this is what we're really looking at today, is there's what we call the iBGP full mesh rule. Routers will not pass iBGP learned routes or internal BGP learned routes to another router via internal BGP, via iBGP. Okay, so inside this autonomous system right here, we'll be setting up iBGP, and so any routes that router 4 learns from router 7, router 4 cannot turn around and tell those iBGP routes to router 5 and router 6 or any other peers. And so because of that, we have to have a full mesh. Now, a couple of ways that you can get around this is you could set up route reflectors, or we could set up confederations, and we'll be talking about those in future videos as well. Okay, so with this in mind, as I said, we've got this great topology already set up. The IP addressing is already set up. As a matter of fact, we've also already set up OSPF so that each of the routers can communicate with all of the other routers. I'm going to do a show IP route here on router 4. And so we can see from router 4's perspective, router 4 being right here, router 4 is right there. From router 4's perspective, router 4 can reach all of the other routes, router 8, router 9, router 5, router 6, router 7. Okay, so these are all the loopback interfaces of the other routes, of the other routers. Okay, and so for that purpose, router 4 is going to be able to ping any of those loopback interfaces on the other routes, as well as their physical interfaces, because it's been learned via OSPF. Okay, so I just caught something here and noticed that on router 4, router 4's network or loopback interface was configured with a /24, and it was supposed to be a /32 per our topology here. So I wanted to correct that really quickly. So I just jumped in and corrected that. All right, so router 4 is able to reach all the other routers in the topology via OSPF. So with that being said, we're all set up now to be able to go into the lab itself. And so the lab goal is we're going to create a full mesh iBGP topology, and we want to ensure that all loopback interfaces are accessible via OSPF first. We already did that. BGP peerings are going to use the physical interfaces, and we want to ensure that all loopback interfaces are advertised via iBGP, and that's going to be a network statement. And so I've already set up a little notepad here, and I'm just going to sort of walk through what I've set up in the configuration here, and then we're going to copy and paste the snippets of the configuration into the separate router. So for router 4, we've got router BGP is 65047. That's the autonomous system number. There's the network statement that we just indicated. Ensure that all loopback interfaces are advertised via iBGP. That's that network statement right there. So we're advertising the loopback interface. It's a 32-bit mask. That's one of the reasons why I went to make sure that was corrected, because otherwise that wasn't going to work. And then we've got neighbor statements to each of the physical interfaces for the other routers for 5, 6, 7, 8, and 9. So these are the physical interfaces, and we're using the same autonomous system number for each. Okay, same autonomous system number on the local end as well as on the remote end, the remote autonomous system. And so this is how you set up iBGP, or internal iBGP. Okay, and so this same setup is on each of the other routers. Each of the routers is just configured to peer with the other routers other than itself. Okay, so router 4, router 6, router 7, router 8, and router 9 on router 5. Okay, so it's pretty basic, pretty simple, pretty straightforward. So we've got each of these neighbor statements that we'll be dropping in and setting up iBGP. So in order to do verification on this, what I'm going to actually do is I'm going to turn on, I've already configured an access list. I've set up an access list on router 4, and we're going to turn on debugging. We're going to turn on IP packet debugging. Okay, so debug IP packet. So all IP packets will be debugged. However, you never really want to turn on IP packet debugging, for all IP packets. You want to configure an access list that gives you more specific details, that filters out some of the extra noise. Okay, so here's the access list that we've created. Access list 101, permit TCP. Okay, because once again, BGP is a TCP application using TCP port 179. So we're going from any source to the destination of 45.5. We're just specifically looking at communication between router 4 and router 5 here, and then another line which reverses it. Okay, so anything coming from router 5 as a host going to router 4, or any here. Okay, so I've already added this access list to the configuration. Okay, and I'll just go ahead and just do it again, just so you see it being done. Okay, so that's there. Show run. Go down and we'll see the access list here. See that access list having been configured there. Okay, that access list is there. All right, and then we're going to go and do a debug. We're going to turn on this debugging. I'm going to do, and so you can see it there. Debug IP packet, and notice you could simply specify the access list number here, but we're going to get some additional details here, a little bit more specific, and so access list of 101. Okay, so we turn that on, and now we're going to go and copy and paste. We're going to go and turn on BGP on router 4, config T, drop it in there, and immediately you should begin to see some debugs, or where we'll see attempted traffic from router 4 going over to router 5. Okay, because once again we're just debugging the communication with router 5. So you should see an attempt to set up a TCP peering session, but it will fail. So we'll do a SYN, SYN, SYN for synchronized bit, and then we're expecting an ACK back. But what will happen is the ACK that comes back would be an actual ACK and a reset. Okay, so here's what we've got. Source router 4 going to destination router 5. Okay, TCP. The source is a randomly generated non-well-known number. Okay, from which would be above the number 1024. And then the destination is a specific well-known port number of 179, which is used for, which of course is used for BGP as we established before. There's a synchronize. Okay, so this is a SYN message, but the message that we get back from router 5, okay, to router 4 is, I acknowledge that you're trying to set something up with me, but the connection is resetting because I'm not configured to respond and to set up the three-way handshake that would normally happen with BGP, or what should I say, with TCP. Okay, so now we're going to go into route. We're going to go and add the configuration to router 5, and you'll see some different behavior here on router 4. So router 5, we're going to drop in all this configuration. Now notice all we really need is this line right here. That much right there, router BGP and the network statement and that neighbor statement for router 4. But I'm just going to go ahead and copy everything in and go ahead and set it up for all of the neighbors. So now, by the way, if I do a show IP BGP, yeah, if I do a show IP BGP summary, okay, notice router 5 is not up. Okay, it's showing state of active. Active is bad. A blank right here would be good. That would mean it was established. So right now we're waiting for the BGP session to establish. Okay, notice it shows BGP neighbor is up over here. You might not see it. We might. There was a lot of debugging activity here, so we don't really have to see it on router 4's end, but you will see that the behavior is different now. Let's see. So router 4 does a SYN. There's that SYN again. Okay. Router 5 now sends back a response, but the ACK, it's an ACK. Let's turn off debugging just so that we can analyze that. Okay, so the SYN goes out here, and now router 5 sends back an ACK, but also a synchronized. So saying, hey, I want to talk to, hey, I hear that you want to talk to me. I want to talk to you too. Then router 4 right here, okay, does an ACK of the SYN that router 5 sent. Okay, so that's now the three-way handshake. Okay, so there's the ACK, there's a SYN, there's the ACK for that SYN, there's a SYN on the other end, and then ACK for that SYN. Okay, that matches. Okay, so now we have an established BGP connection right here. Okay, now we're established. Okay, and so now when we look at that same output from just a moment ago, up arrow a couple of times, show iBGP summary, you'll notice that the peering to router 5 is established. Once again, I mentioned that blank is good. Okay, so now we see that it's been up for a little while here, and that's now established. So now we have that established peering session between routers 4 and 5. Now to take this a step further, I could do a couple of other show commands, show iBGP. By the way, I'm going to scroll down here so you see some of these commands that we'll look at. By the way, show iBGP neighbor, BGP neighbor, and we see that we do have one neighbor that is established. Okay, one neighbor established. We're up. Keep alive, 60 seconds, etc., etc. We're just doing IPv4 unicast. Okay, the remote AS. This is an internal. Or iBGP session. So if I do a, let's go to show iBGP. Notice here that's my own network. That's my own loopback interface on router 4, but I've also learned the loopback interface of router 5. Notice you see an I right there, internal. Okay, I for internal. See the greater than bracket indicates the best route, so best path, the best route for that particular one. And notice here that we've got that network learned from router 5. Okay, so I'm going to go ahead and add in the other configuration for the other routers, so we can focus on the rest of this verification. Okay, so config T, copy that in. We should see neighborships begin to come up between the rest of these guys. Router 7, drop that in. Router 8, okay, and notice all I did in setting these up was a lot of copy and paste and just making sure that each one was peering to the appropriate interface on the other end. Okay, so once again, it's a full mesh configuration that we're setting up here. So that means there's a neighbor statement to every other router each time. So router 9, now we're going to set that up as well, and bam. So with that being said and done, we can go back to router 4, and remember just a moment ago we did show IP BGP Summary. Show IP BGP Summary was showing active for all of those guys, but now they're all showing up. Okay, they're showing established, and show IP BGP, just show IP BGP, which shows the BGP network table, or the route to the table. And okay, so now we have learned 5, we've learned 6, we've learned 7. Okay, give it a little time and it'll learn 8 and 9 as well. There we go. Okay, all right, so iBGP neighbor, show IP BGP neighbor on router 4. Each of these neighbors is now established. Okay, notice that the best path from this peer, we've got some iBGP peer information here. Best path from iBGP peer, that 4 listed there. So here's another okay, here's another neighbor. Okay, so notice there's a lot of information that comes up for each neighbor when you simply do the neighbor statement, show IP BGP neighbor. Notice this TTL thing right here. Let's just take a look at a few items here. Let's go. All right, so the neighbor, the remote AS, the BGP version, the remote router, of course, keep alive, the hold times and keep alive. Remember, the hold time is 3 times the update interval, the keep alive interval for BGP. Just go down, neighbor capabilities. Notice it's able to do route refresh, advertised networks as well as received networks, old and new, advertised and received networks for IPv4 unicast. Go down a little further and we're going to see the prefixes and activity here. All right, one prefix, okay, that being that loopback interface. Okay, and let's see, here we go. Yeah, check that out. Localhost, port number, okay, foreign port number. So this is a non-well-known number right there locally. Okay, so if we went back to that debug output back here, we should see that that is that source port number right there that we used to establish this neighborship with router 5. Okay, so that's the reason why we see that. Where was I? Local host. There we go. Okay, local port, and of course the foreign port being TCP 179 for BGP. There's a TTL there. I was just about to talk to you about this TTL back here. Okay, so the TTL of this outbound session is set to 255. Because of this, I'm sorry, because this is a because this is an iBGP session. That's the reason why we see that TTL being 255. This means that the iBGP neighbors don't have to be directly connected. Okay, with eBGP, we need directly connected neighbors. Okay, they have to be directly connected, and so the TTL with eBGP is going to be 1, whereas here notice the TTL for iBGP neighbors is going to be 255. Okay, so remember, iBGP neighbors don't have to be directly connected as long as there's IGP reachability. IGP reachability in this case is being done through OSPF. And remember, eBGP sessions have a TTL of 1, and so we saw the local port, foreign port. We've taken a look at show iBGP summary. Let me think if there's anything else that I'm wanting to show you from the outputs here. Okay. Show IP BGP summary. Okay. Yeah, it's pretty straightforward. Once again, this is a great command to see all of your, to see actually all the neighbors. This is what I would consider a better command than using the iBGP neighbor command, because it gives you this nice little chart just to sort of summarize and see all of the neighbors in one fell swoop there. Okay. Another couple of commands that we can do here. Let me do show IP BGP one more time. And remember, here we're seeing all of the networks that have been learned there. But if you do a show IP route, notice those networks are still here as having been learned via OSPF. The reason being is OSPF's metric. If I do a show IP protocols, OSPF's metric or administrative distance is 110, whereas for BGP, okay, we're using iBGP or internal BGP. So the metric that we have for iBGP is 200, and so that means that these networks that we've learned via iBGP are not going to be inserted into the routing table. However, if I do a show IP show IP route BGP or show IP show IP BGP route. Oh no, we'd have to use a route map. Let's see, show IP BGP, show IP route BGP. Well, right now we're not learning any of those routes via BGP, and so therefore they're not making it into the routing table. Show IP route BGP, they aren't going to show any of them in the routing table right now, because they are in the OSPF, because they're learned via OSPF. Okay. If any of them weren't learned via OSPF, then we'd see that in the routing table, in the BGP routing table. All right. So if we want to, let's do something here. If we want to show IP we could do a show IP route 172.16.0.9 0.9. Okay. All right, so we're seeing that that's learned via OSPF. I'm gonna add another layer to this and see if we, let's see, interface loopback 9, IP address 99.1. Let's see, 99.0.0.9. Sorry, 9, and I'm gonna do. So I put that into the routing table. So do show IP route. And so we see this now in the routing table. I'm going to add this guy to BGP to be advertised. Router BGP 65047 network 99.0.0.0 .0. Oh, mask. Yeah, I have to use the keyword mask there. Okay. Show IP BGP on router 9. So now I've added this network into router 9's BGP. Okay, so it would be advertising this network right here. So his BGP peers should now see that 99. Okay, with that in mind, let's do show IP show IP route BGP, and so now you see a BGP learned route. Okay, and so I'm going to do a recursive lookup now for that instead of this network right here that I had indicated. 0.0.9. So changing that around there. So I've added a network to router 9, and I'll update the file a little bit later. But so add loopback 9 to R9 and advertise into BGP. So that's what we just did there. Okay, so we're adding another layer to our little lab here. Okay, just so that we see something very specific that I want to show you here. I did want to show you a recursive lookup. So show IP route 99.0.0.9. Oh, before I do that, I'm just going to do a show IP route, and we now see a BGP learned route there. Okay, so 99.0.0.9. So notice this routing entry here shows us that we have learned this route via 10.10.79.9. Okay, what we're doing here is we want to find and we want to figure out what physical interface is this going out of right here. So when we look at this routing table, we don't see a physical interface for that network right there. Okay, and 10.10.79.9 doesn't show up here in the routing table to show a physical interface. So we need a recursive lookup to be performed in order to be able to find the outgoing interface. Okay, so we start off by doing the recursive lookup. So we're looking up that specific network. Okay, so we see that it's been learned via BGP, administrative distance of 200, just as we indicated before, being the administrative distance of internal or iBGP routes. Okay, so now we need to do a lookup of this network because we still don't see the specific interface. So show IP route, and we're going to take a look at that. Okay, and so now that we have that 10.10.79.9, we've learned that route through 10.10.47.7, okay, which now we see we're going out of Fast Ethernet 00. And of course, we could take this a step further. We could take it a step further and do 47.7, but we really don't need to. The recursive lookup is performed simply by taking a look at the next hop addresses here. Okay, so that next hop address from a BGP perspective is 79.7.9 there, and now we reveal that in order to reach that network, we'll go through the 47.7 next hop, which goes through Fast Ethernet 00 as our outgoing interface. Okay, and let's see if there's anything else that I want to show you here. We've talked about the recursive lookup. We talked about the BGP neighbor statement. Okay. Oh, just for kicks and giggles, I want to show you this command right here: show IP BGP IPv4 Unicast Summary. Now, actually, what's going to happen is you're going to see that this is same information that you got from the show IP BGP summary command, but the advantage to showing you this command is in very large networks, very large environments where we've got a lot of different routing protocols and a lot of different address families running. It's important for you to be able to filter out some of the additional noise, and so by using this command right here, you get just those IPv4 unicasts in a separate table all by itself. Okay, so in this environment, in this small lab environment, it's identical to the show IP BGP summary command. Okay, but in a larger environment where a lot more stuff is running, you would find that to be advantageous in those environments, because it'll filter out some of that additional noise. So in summary, we have ensured all loopback interfaces. We've set up BGP peerings to use the physical interfaces, and we've verified that. We can verify that here, and on any of the routers here, we've got the iBGP peerings all established. We have a full mesh to all of the routers 5, 6, 7, 8, and 9. From router 4 here, we've checked the BGP table itself, looked at the learned routes. We've also done a recursive lookup. We added that little layer into our lab. And so we've got iBGP full mesh all working now. We'll see you in the next video. I'm Raleigh Jones, CCIE 37264 with Router Beast. Thank you guys for joining me. See you next time.